Hi everyone. So in the previous video we have seen the clamper circuit. Now we are going to see how to solve those clamper circuit in just one step. Although these are two steps, not one step, but still we are going to see how to solve the problem very quickly. So you might not be able to understand the procedure by just reading the statement, but once we apply it in a question, you will be able to understand it. So what they are saying, first you have to turn on the nearest diode to the supply. Okay, you will turn it on. How will you turn it on? If a negative side is there, so you will give negative supply. If positive side is there, you will give positive supply. Then once you turn on, you will find the voltage across the capacitor. That will be its steady state voltage, and then you can write the output. So this is just the statement. Let's see it in a question. So this question is given in front of you. You need to find the steady state value of V0. Steady state V0. First we will solve it by this method, by this one. And then we will solve it by conventional method that we understood in the previous video. So first we will solve it in one step only. So how we will solve it? So what did I say? You have to turn on the diode. This diode has to be turned on. So tell me how it will be turned on. At what voltage it will be turned on? At Vm it will be turned on? No, it will be turned on at minus Vm, right? So you will apply Vi equals to minus Vm. So when Vi is equals to minus Vm, what will happen? Diode turns on. Diode turns on. Now if the diode turns on, how will the circuit look like? Diode turns on. Now your target is to find the voltage across the capacitor. That is your target. If diode turns on, this is your Vin. Vin, applied Vin is minus Vm. It is minus Vm, and this is the capacitor. So this is your input. So how you can write it? You can write it in other way as well. You can write it like this: minus plus Vm, because this is your applied input, plus minus, and that is negative. So you can interchange the polarity. So this negative will go upward, this positive will go downward. So this would be plus minus Vm. So how will the capacitor charge? The capacitor will charge in this direction. So what will be the voltage across the capacitor? The voltage will be Vm, but in this direction, opposite direction. If I call this as Vc, this potential as Vc, so your Vc is minus Vm actually, because the capacitor is getting charged in the opposite direction from right to left. Are you getting this point? Very easy point. It is getting charged from right to left. So this is minus Vm. Now this is the steady state voltage of capacitor. Steady state capacitor voltage. Now it will never be changed. It is never going to change. Steady state capacitor voltage. What did we do? First we turned on the diode. Diode will turn on at Vm? No, it will turn on at minus Vm. So at minus Vm we turned it on. So if diode is on, so what will happen? Here at the input, minus Vm is applied, so same voltage will be given towards the capacitor. So capacitor will also be charged with minus Vm. That means it is charged from right to left by Vm voltage. So what will be your output now? What will be your output? So let's make the main circuit. Our target was to find the voltage across the capacitor. That we found, and that is this. This is Vm, and then there is this diode or whatever it is. We don't need to think about it. We just needed the voltage across the capacitor. That we have found. This is resistance R. This is V0, and this is our Vin. This is our applied input, and Vm is the voltage, steady state voltage across the capacitor. So what will be our output? Output will simply be Vi plus Vm. That is our final output. Vi plus Vm. That is our final output. That's it. Done. In just one step it is done. What did we do? First we turned on the diode. How it will be turned on? With the negative supply. Then we got to know the voltage across the capacitor. That is its steady state voltage. The steady state voltage is Vm from right to left. So what will be your V0? Vin plus Vm. That's it. Let's go to the previous questions that we solved. Let's go to this question. This question we solved. So when will the diode turn on? The diode will turn on at any supply. At any positive supply it will turn on. But we have to see the maximum supply. What is the maximum supply? That is plus 5. So diode will be turned on at plus 5. So when my input is plus 5, diode will be turned on. If my input is plus 5, how much voltage will be there across the capacitor when diode turns on? It will be plus 5 only. Right? This will be plus 5 volt only. So this is the steady state voltage of the capacitor. If this is the steady state voltage of capacitor, so what will be output? Output will be Vi minus 5. Vi minus 5. That would be the output. That's it. That is our final answer. And you can check this was our steady state voltage. So in the question, if they are asking only the steady state voltage, you don't need to think much about it. You can just see, first turn on the diode. Okay, what is the voltage across the capacitor? Okay, 5 volt is there. That is the steady state voltage. Now what will be my output? V in minus 5. That's it. In one step only you will be able to solve. And most probably they will just ask the steady state voltage. They will not expect the analysis, but in some question paper they can expect the analysis as well, but most probably they ask the steady state voltage only. Now let's do the analysis of this question. Let's do the analysis. This was just the method, right? This was the method to find the steady state output voltage. Now we will do the exact analysis. Let's do the exact analysis. What we will do in the exact analysis? First we will see the applied input is Vm. Applied input is Vm. So when Vin is equals to Vm for 0 to t by 2, let's call this as t by 2 and this as t. So for 0 to t by 2, for time 0 to t by 2, applied input is Vm only. And if applied input is Vm, that means diode will not be on, because this Vm will be coming across the diode only, because capacitor is having no voltage. So the complete voltage will be coming across the diode. So what is happening? Diode is off. And if diode is off, how will the circuit look like? Simply like this. And it will be given that RC value is very large. Given that RC very large. It will be given in the question itself. RC is very large. So it is given that RC value is very large. This is C, this is R. This is plus minus. You can write like that. Plus minus Vm. And this is V naught. So RC value is very large, so capacitor will not charge, neither discharge. Neither charge, neither discharge. Nothing will happen. So simply Vc will be 0 volt only and V naught will be plus Vm only. Now what will happen for t by 2 to t? For t by 2 to t, input is minus Vm. If input is minus Vm, what will happen? If input is minus Vm, what will happen? Diode will turn on. Diode turns on. And if the diode turns on, what will happen? This will be the condition. This exactly the same condition will be there. So I guess I can copy it directly. Array. Better I should make it. The diode turns on. So this will be the condition. Now applied input is minus Vm. So this is the direction. Now capacitor will get charge in this direction. This is our Vc, and this is V naught. So currently what is your V naught? V naught is 0 volt, but what is your Vc? Vc is minus Vm. Now when will the diode turn off? In the next cycle, what will happen? Plus Vm would come, right? What will happen in the next cycle from t by 2, from t to 3t by 2? From t to 3t by 2. Applied input is plus Vm. So this is our circuit where capacitor is charged to Vm and diode is looking something like this, right? This is our diode. And input is plus Vm. And this is V naught. The resistance R is there, but I am not making it. Forget about it. So what will happen? Vm plus Vm. So here diode will be off. Diode will be off. And now it will always be off. Why so? Because to turn on the diode, what should happen? To turn on the diode. This was actually our V in only. So to turn on the diode, what should happen? V in plus Vm should be less than 0. That means your V in should be less than minus Vm. V in plus Vm, this potential is V in plus Vm, that should be less than 0. Then only diode will turn on. But that is not going to happen. For that you need V in value to be less than minus Vm, which is not possible because V in is never going below minus Vm. So this is not possible, and if this is not possible, that means diode will always be off. Will always be off. So particularly this is our steady state only. So what will be your V naught? V naught will be V in plus Vm. So simply your input will be increased by Vm. So we can draw the final output. So in the output, what was happening? Initially, for first cycle, for 0 to t by 2, V naught was Vm only. V naught was Vm only. Then what was happening? V naught was Vm only. Then what was happening? V naught was 0. Then V naught was 0. Then what happened? In the next cycle, for 0 to for t to 3t by 2, it has increased to 2 Vm. It will be 2 Vm. Then when Vin is minus Vm, it will be 0. When Vin is Vm, it will be 2 Vm. You got this, right? When Vin is minus Vm, the output will be 0 only. So in this way, it will keep on going. So this time is t. This is 3t by 2, and it will keep on going. This is 2 Vm. This is 0. So they will ask you the steady state output only. This is not the steady state. This was there for just for one cycle only. After that, steady state is reached. After that, steady state is reached. So this was there only for one cycle. So after that, 2 Vm 0, 2 Vm 0, 2 Vm 0. This is what you will see. Well and good. Let's move on to the next problem. Try solving it on your own. You just need to write the steady state output. How will you write the steady state output? First, you need to turn on the diode. How will you turn on the diode? At Vm, it will turn on? No. At 0, it may turn on, it may turn off. But let's assume if it is turned on. If it is turned on at 0, what will happen? When applied input is 0 from t by 2 to t, when Vin is 0, the diode may turn on. Let's assume it is turning on. So what will happen? Applied input is 0. So capacitor will be charged to 0 voltage only. So the steady state voltage across the capacitor is 0 volt only. The steady state voltage across the capacitor is 0 volt only. Then what will be your output? Output will be simply equals to Vin, because the capacitor is not charged. So simply complete input is going across the output. That's it. So V out will be equals to Vin. That's our steady state. Understood this question? What was our method? What was the method? That you need to turn on the diode. At Vm, it can't turn on. There are only two input, Vm 0, Vm 0, Vm 0. So at Vm, it can't turn on. It can turn on at 0. We are not sure it turns on or turn off, but let's assume it turns on at 0. At 0, the diode turns on. If it turns on, what will be the capacitor voltage? It will be 0 volt only. So the steady state voltage across the capacitor will be 0 volt only. If it is turned on like this, and here 0 volt is applied, so what will be the voltage across the capacitor? 0 volt only. So steady state voltage across the capacitor is 0 volt only. No one can change that. So what will be your output? Output will be simply V naught equals to Vin. Because let's assume this is Vc. So Vc steady state will be 0 volt only, right? Vc steady state will be 0 volt only. So what will be your V naught? V naught will simply be equals to Vin. So there is no shifting upward or shifting downward. So output is simply equals to Vin. No shifting upward, no shifting downward. This is the steady state output. That's it. Always V out is equals to Vin. That's why I took this question. Like people may get confused. Okay, what will happen now? So nothing will happen in this question. Okay, V naught is equals to Vin. Now if you just see this question, okay, it will be clamped up. So someone will say, okay, it will be clamped up by Vm amount. So they may do that 2 Vm, Vm, 2 Vm, Vm, but it's not going to happen. Okay, so you just don't need to mug up anything. You should have the aptitude to apply in the examination. You just need, what is the method I told you? Just turn on the diode first, 0 volt, turned on. You need to find the capacitor voltage. Capacitor voltage is 0 only. So what is V out? V out is simply equals to V in. Let's move on to the next problem. Okay, let's shift it downward a bit now. So yeah, now you can see the question. So tell me, when will the diode turn on? When applied input is minus Vm, right? When applied input is minus Vm. If the applied input is minus Vm, the diode will turn on. So what will be the voltage across the capacitor at that time? When diode turns on, the voltage across the capacitor will be minus Vm only. So the capacitor is getting charged in this direction because the applied input is negative. So it will be charged like this. Well and good. So what will be your output? Output will be Vi plus Vm. That's it. Got the point? Let's write it in a better manner. So what did I say? When Vi is equals to minus Vm, diode turns on. When Vi is equals to minus Vm, diode turns on. So what will be the condition at that time? At that time, you just need to find the capacitor voltage. This applied input is minus Vm. You can write it in this manner. This is your minus Vm. Now your capacitor is getting charged in this direction. Capacitor will be charged like this, right? And if I am calling this as Vc, this as Vc, so Vc steady state would be minus Vm, right? Now you just need to find out the output voltage. So what will be our output voltage? This is the capacitor, this is your V naught, this is your V in. No need to write the complete one. This is charged to Vm only. So what will be my output voltage? Output voltage will be Vi plus Vm. That's it. So this complete input will be shifted upward. This complete input will be shifted upward. That will be our steady state output. Steady state output. Well and good. Vi plus Vm. Let's move on to the next question. Try solving it on your own. What will happen? First, Vm, you need to turn on the diode. How? When will diode turn on? When Vin is equals to Vm only. When Vin is equals to Vm, the diode will turn on. If the diode turns on, what will be the voltage across the capacitor? That will be plus Vm like this. If diode turns on, the capacitor is getting charged in this direction because it is turning on and plus Vm. So capacitor voltage will be plus Vm like this. So what will be your output? Output will be Vi minus Vm. That's it. Well and good. Are you able to grasp the point? Now if you want to, you can solve all those questions by the conventional method as well. Like first, okay, Vm is applied, so diode will be turned on. It is charged to Vm. Now minus Vm is applied. So if minus Vm is applied, so minus Vm, minus Vm. So minus 2 Vm. That means diode is off. Now if the diode is off, it will always be turned off. So my final output will be Vi minus Vm. Right? So when Vi is equals to Vm, diode turns on. And if diode turns on, what will be the condition? This will be the condition. This will be the condition. This is the capacitor C, so it will be charged for Vm only. And let's assume we are calling this as Vc. So Vc steady state would be plus Vm only. This is our Vc steady state. So what will be our steady state output? No need to make the complete circuit, just the capacitor voltage and the input. This is your input Vin, this is your capacitor voltage Vm, and this is your output. V naught steady state is V in minus Vm. That's it. And here also you can see that this is a negative clamper. So it is shifting the waveform downward. So how will the output waveform look like? 0 minus 2 Vm, 0 minus 2 Vm, 0 minus 2 Vm. It will shift down the waveform. When Vin is equals to Vm, output will be 0. When Vin equals to minus Vm, output will be minus 2 Vm. When Vin equals to Vm, output will be minus 2 Vm. Sorry, when Vin is equals to Vm, output will be 0, and when Vin equals to minus Vm, output will be minus 2 Vm. So 0 minus 2 Vm, 0 minus 2 Vm, 0 minus 2 Vm. Let's move on to the next one. This what you will do? You have to turn on the diode. When will the diode turn on? When applied input is equals to Vm only. When Vin is equals to Vm, diode turns on. And if the diode turns on, what will be the steady state capacitor voltage? Steady state capacitor voltage will be Vm in this direction. This is Vc. Vc is equals to Vm. Right? Now, what will be my final output? This is my Vm and this is my applied input and this is my output. Output will be Vi minus Vm. Well and good. So this complete waveform will be shifted downward. So 0 minus Vm, 0 minus Vm, 0 minus Vm, like that at the steady state. In the first cycle, there can be something different. In this cycle, there can be different scenes, but at steady state, it will be completely shifted downward. 0 minus Vm, 0 minus Vm, 0 minus Vm. We have seen in these questions that in the first cycle, the scenes are different. In the first cycle, look here, it is 0. So in the first cycle, scenes are different, but at steady state, V0 will be V minus Vm. In the previous one as well, you can see in the first cycle it is similar like this, but at the steady state it is following like this only. V0 is equals to Vi plus Vm. So in the first cycle the scenes will be different, but they will only ask you the steady state value. And even if they ask you the value in the first cycle, what you can do? You can analyze the circuit. I have taught you good enough that you can analyze the circuit, right? First you will see the input. Okay, this is the input, so output will be 0 for the first cycle. For 0 to T by 2, output will be 0 only, because the diode is turning on at the time. It is turning on for the first time. So it is turning on for the first time, so the output will be 0 only for 0 to T by 2. Then what will happen? When you apply the 0 voltage at that time, diode turns off. And if it is turned off, it will always be turned off only. So the steady state voltage across the capacitor will be plus Vm only. So output will be Vin minus Vm. Vn minus Vm. Well and good, you can analyze the circuit on your own, but here we are just seeing the steady state output. So let's move on to the next one. Here you tell me what will be the steady state output. When will the diode turn on? When applied input is minus Vm. When Vn is equals to minus Vm, will the diode turn on? No, the diode will not turn on. So diode turns on at 0 voltage. It may turn on, it may turn off, but you are not sure about it. But let's assume even if it turns on at Vn equals to 0, if the diode turns on, what will happen? The steady state voltage across the capacitor will be 0 volt only, right? I am assuming that at when Vn is equals to 0 volt, I am assuming the diode turns on. If it turns on, still the voltage across the capacitor will be 0 volt only. At minus Vm, it is not turning on, that's for sure. But even if it turns on at Vn equals to 0, still the capacitor voltage will be 0 only. So if capacitor voltage is 0, so V0 will simply be equals to Vin only. So here you can see that Vc steady state will be 0 volt. So Vout steady state will always be equals to Vin only. Well and good. Did you understand it? When I apply 0 volt here, I am assuming the diode turns on. If the diode turns on, that means the voltage here will be 0 in this direction, you can say. Yeah, so if I am applying 0 volt here, I am assuming diode turns on. So still the voltage will be 0 volt in this direction. Still there is no charge on the capacitor. So this is the steady state voltage across the capacitor. Steady state voltage across the capacitor is 0 volt only. So what will be your output? Complete input will be going towards the output. So Vout will be simply equals to Vin. Well and good. Let's move on to the next problem. So okay, now we are going to see clamper circuit with the bias. The input I haven't shown here. The same applied input is there. This input, sinusoid 5 sin omega t. I should at least write here. The input is 5 sin omega t. So analyze this circuit on your own and tell me the steady state output. You can tell the steady state output, but for this question we are going to see the whole approach, not just the steady state output, but at least you can tell me the steady state output. How will you tell me the steady state output? When will the diode turn on? The diode can turn on at any supply, but we have to see that at any positive supply, but we have to see the maximum positive supply. What is the maximum positive supply? That is 5 volt. So when Vin is equals to 5 volt, the diode will turn on, right? And if the diode turns on, what will happen? If the diode turns on, what will happen? This is the capacitor, diode turns on. That means diode will be shorted, and here it will be 1 volt, and here it is 5 volt. This is 1 volt, this is 5 volt. So by how much voltage the capacitor will charge? By 4 volt only, because this end of capacitor is at 5 volt and this end of capacitor is at 1 volt. So what will be the steady state voltage across the capacitor? That will be 4 volt. 5 minus 1, 4 volt. So steady state voltage across the capacitor will be 4 volt, right? So let's first solve it by the method. So by the method, when Vin is plus 5 volt, maximum positive supply. At that time, diode is on. Diode is on, right? So this is the capacitor. If diode is on, then that means this will be 1 volt. And here I am applying 5 volt. And this I am calling as Vc. So what will be my Vc steady state? Vc steady state will be 5 minus 1. That will be 5 minus 1. That will be 4 volt. So my Vc steady state will be 4 volt. In the next step, what we do? We just find the final output. So how will we find the final output? This end is your final output. Simply this end is V0. So this is your V0, and this end is Vin. This end is Vin, and this capacitor is charged to Vc is charged to 4 volt. This capacitor is charged to 4 volt. So what will be your V0? V0 steady state will be what? Vin minus 4. So it is clamping down, but it is not clamping down with the maximum voltage. It is clamping down with 4 volt. In the previous analysis, when this 1 volt was not there, it was clamping down by Vin minus 5. But now this 1 volt is there, so it is clamping down with lesser voltage. Now tell me one thing, I am asking you one question. If you want me to clamp it down by more voltage, if you want the output V0 equals to Vin minus 6, so what will you do? You want the output Vin minus 6, so what will you do? You will change the battery to minus 1 volt, right? Because if you want your output to be Vin minus 6, that means you want your capacitor to be charged to 6 volts. If you want your capacitor to be charged to 6 volt, that means you need to put a minus 1 volt battery here. So if you put a minus 1 volt battery here, the capacitor will be charged to 5 minus 1, that means 6 volt. So your steady state output will be Vin minus 6. That's it. Able to visualize everything? So this was the what we say, this was our shortcut, but now we will see the conventional method. Or what name did we use for that? Exact analysis. Okay, let's see the exact analysis. This was just the approach, this was just our method, but let's see the exact analysis now. Exact analysis. So at t equals to 0 plus, what is happening? Vin is greater than 0. That means Vin is greater than 0. That means capacitor is not charged. So simply the diode will turn on. The diode turns on. And if the diode turns on, what will be the condition? This is the capacitor C. This diode is turning on with 1 volt, and here your input is there. Now your input is increasing from 0 to 5 volt. So the capacitor will be getting charged. So here this we are calling as Vc. So the diode turns on. So for 0 to t by 2, what is happening? The diode remains turned on only. Diode remains turned on only. Why so? Because I told you one thing, whenever the input is changing its nature, then only you need to worry about it. From 0 to t by 4, okay, t by 4, again and again I commit this mistake, for 0 to t by 4. So whenever the input is changing its nature, after that you need to think. but till the time it is not changing its nature, it is increasing till that time you can be comfortable, right? So at t by 4, so what will be the Vc value at t by 4? First I will write the input value. Input value at t by 4 is 5 volt. V in at t by 4 is 5 volt. So what will be your Vc value at t by 4? That will be 5 minus 1, 4 volt. Vc value at t by 4 will be 4 volt. And what is your output? Output from 0 to t by 4 is 1 volt only. That is fixed at 1 volt only, because this is your output, right? This is your output, which is fixed at 1 volt only. So what is happening? Vc is simply following the input till this time. Vc is following the input. And output is fixed at 1 volt. Right, and this is 5 volt. Now at t by 4 plus, what is happening? At t equals to t by 4 plus, what is happening? Your applied input will be lesser than 5 volt. Let's assume 4.9 volt. So I guess I should do it on the next page only. At t equals to t by 4 plus. So let's make the diagram first. This is charged to 4 volt in this direction. This is a resistance R, which is very large, but I just making it, but there is no need of it. This is 1 volt. This is resistance R, this is V naught. So what is happening? Let's assume at t equals to t by 4 plus, V in voltage is 4.9 volt, somewhat lesser than 5 volt. We are assuming it at t by 4 plus. Here, somewhat lesser than 5 volt. Let's assume it is 4.9 volt. So if this voltage is 4.9 volt, 4.9 minus 4, this voltage will be 0.9. This is 0.9 and this is 1. What will happen? Diode turns off. Diode turns off. And if the diode turns off, what will be your output? Your output will be V in minus 4 volt. That's it. That's your steady state output. And if the diode turns off, to turn it on, what do we need? V in minus 4. V in minus 4 volt should be greater than 1 volt. Not greater than 0. Should be greater than 1 volt. This potential should be greater than 1 volt. Because P side should have more potential than the N side. N side is already having 1 volt. So V in minus 1 should be greater than 1 volt. So V in should be greater than 5 volt, which is not possible. That means diode will always be turned off. So diode always off. Diode will always be off. And once the diode is off, the capacitor can neither charge neither discharge. So it will remain at 4 volt only. So what will be your output? Output will be V in minus 4 volt. That's it. Well and good. Understood? We have also seen the conventional, we have also seen by the method. Now we have also seen the exact analysis. Now we can draw the final waveforms. So, okay, it was reaching till 4 volt only, not 5 volt. It was reaching till 4 volt only, and it remains at 4 volt till steady state. What about your V naught? V naught will be V in minus 4 volt in the next cycle itself. When it is 5 volt, it will be okay. When it is 4 volt, it will be 0 volt. So like that it will go on. And when it is 0 volt, it will be, when it is 0, it will be minus 4. And when it is minus 5, it will be minus 9. So till minus 9 it will go. This voltage is minus 9. And when it is plus 5, when it is plus 5, it will go till 1 volt, because when it is plus 5, it will be, output will be 1 volt. Output will be 1 volt. Till this point I should make it. And then it will again follow this input only, like this only. It will keep on going like this. It will follow like this only. Well and good. This point is minus 9. Minus 9 volt. Well and good. Let's move on to the next problem. This problem, you just need to tell me the steady state V0. We are not going to do the exact analysis, just tell me the steady state voltage of V0. Try doing it on your own. You should be able to solve this problem. You should be able to solve this problem. Okay. So when will the diode turn on? What is our input? This is our input. Sinusoid input. It has two peaks, plus 5 and minus 5. It will keep on going like this. This I am calling as plus 5 and this I am calling as minus 5 volt. So when will diode turn on? The diode will turn on at negative supply, but the maximum negative supply we need to take. So when Vin is equals to minus 5, when Vin is equals to minus 5, diode is on. I am not writing diode turns on. The diode will turn on at minus 2 volt also. The diode will turn on at minus 2 volt also. But we have to see the maximum negative supply. So maximum negative supply is minus 5 volt. So at the maximum negative supply we are taking. Diode turns on. So what will be the condition? We just need to find the capacitor voltage. So here it is 1 volt. This is 1 volt. And here I am applying minus 5 volt. So how I should write it? I should write it in this manner, minus 5 volt. This potential is minus 5 volt. I can take another color of pen. This potential is minus 5 volt and this potential is 1 volt. So how will your capacitor charge? How will your capacitor charge? Capacitor has charge to 6 volt. 1 volt and minus 5 volt here. 1 and minus 5. You need to take the difference. That is 6 volt. So it is charged to 6 volt in this direction. Charged to 6 volt in this direction. Understood? When Vin is minus 5, the diode turns on the maximum negative supply. So here minus 5 and here 1. That means it is charged to 6 volt. The capacitor is charged to 6 volt. Now what will be your output? How will your output look like? This is 6 volt. This is V in and this is V0. Simply your V0 will be V in plus 6. So it is clamping up by 6 volts. Not by 5 volt but by 6 volt. And if you wanted to clamp it up by 4 volt, what you would have done? You would have simply taken minus 1 volt here. If it was minus 1 volt here, by how much amount it would have clamped up? By 4 volt only, because minus 1 here and minus 5 here. What would be the difference? 4 volt. So the capacitor would have charged plus minus 4 volt. So output will be V in plus 4 volt. So this is our steady state output. So your steady state output is V0 steady state. I can write that is 5 sine omega t plus 6. That is our V0 steady state. That's it. So these kind of questions they can ask in the examination. Well and good, you are following it up. Let's tell the steady state value of this one. Solve it on your own, then just see the final answer. So when will the diode turn on? The diode can turn on at minus 2 volt as well, minus 3 volt as well. Oh, sorry. It can turn on at the supply is minus 1 here. So it can turn on at any point, I guess at 1 volt as well. It will turn on at 1 volt as well, right? Because this is minus 1 minus this point. No, it will not turn on at minus 1. What is the potential of minus? This is minus 1. And let's assume potential of this point will be some minus Vi. That should be greater than 0. So Vi should be less than minus 1, right? Vi should be less than minus 1. So it will turn on at minus 1.1, minus 1.2, but we have to take the maximum negative supply. So maximum negative supply will be minus 5 because this is our input. So maximum negative supply can be minus 5 volt. So when Vin is equals to minus 5 volt, the diode is on. Diode will be on when Vin is equals to minus 5. We just need to find the capacitor voltage, and that we can find. It is minus 5. So you can write it in this manner. This potential is minus 5 volt, and now this potential is minus 1 volt. This potential is minus 5, this potential is minus 1. So this will be charged to 4 volt in this direction, plus minus. This is minus 1, this is minus 5. So what will be the total potential? That will be 4 volt, but from minus 1 direction. So it is charged till 4 volt. So this is the steady state capacitor voltage. And what will be your output voltage? So your output voltage will simply be this will be your V naught, and it is charged to 4 volt, and this is V in here. So V out will simply be V in plus 4. This is your V out. V in plus 4 volt, or you should write V out will be equals to 5 sine omega t plus 4. So it is clamping up by 4 volt. Clamping up by 4 volt. Let's move on to the next problem. Okay, there is no next problem, but there is next circuit is peak detector circuit. So now we are going to study peak detector. After that we will see voltage doubler and tripler. So this is just a 43-minute video only. So should I start peak detector circuit or should I start it in the next video? I guess we can take more example of clamper circuit. So I will try thinking of more example of clamper circuit. Okay, so one more example I guess we can see, and after that in the next video we will see the peak detector circuit. That is very easy, very straightforward. Even peak detector circuit is also very straightforward, but let's try taking one more example of clamper circuit. Okay, so let me make the question, then we will see the solution. Okay, so this is the question that I just now designed. So the input is given, you need to tell the steady state output voltage, also you need to draw the VC waveform. So tell me what will be the steady state output? You should be telling it correctly. There are 4 options. V out equals to V in, no. V out equals to V in minus 3 volt, wrong. V out equals to V in minus 5 volt, wrong. V out equals to V in minus 7 volt, correct. Okay, so output voltage will be V out equals to V in minus 7 volt. Why so? Because I told you, you need to turn on the diode, but at the maximum possible supply. So what is the maximum possible supply? That is 7 volt. Maximum possible supply is 7 volt. So when V in is equals to 7 volt, this is the answer. Maximum positive supply. The diode is on. At that time, diode is on. And at that time, if diode is on, the capacitor will be charged to 7 volt. This capacitor will be charged to 7 volt because this end will be grounded and this end will be at 7 volt only. So this capacitor will be charged to 7 volt. So what will be your steady state output? This is your V naught, this is your V in, and this is 7 volt. Your steady state output will be V in minus 7 volt. That is your steady state output. Steady state output. Along with that, I asked you one more question. You need to draw the VC waveform. So can you draw it on your own? VC waveform. Let's try it. पहले तो इसको थोड़ा सा एक्सीड कर देता हूँ. हो जा भाई. Yeah, okay. Now here we are drawing the final output. Look what is happening. When Vin is 0, when Vin is greater than 0, the diode will turn on. At here only the diode will turn on. At this point only diode will turn on. So what will happen? Capacitor voltage, this is VC actually. This is VC. The capacitor voltage will start following the input. Simply VC will be simply equals to Vin only. If the diode is on, VC will be equals to Vin only. So it will start following the input. It is following till 3 volt it will follow. Now what will happen? The nature is changing. Now this is charged to 3 volt. This is charged to 3 volt. But at the next moment, applied voltage is 2.9. At the next moment only. 2.9 minus 3. Here you are having minus 0.1. Here you are having minus 0.1. And if you are having minus 0.1 here, then your diode will be turned off. If diode is turned off, the capacitor will retain its voltage. It will neither charge nor discharge. Why so? Because RC is very large. So after that, it will retain its voltage. So in the previous analysis, in the previous question, what did we see? It will always, once the diode is turned off, it will always be turned off only. But here, something different will happen. Here what will happen? Here something different will happen at this point. At this point. Also something different will happen at this point as well. So what will happen? Till now our capacitor is at 3 volt only. After this point, at the next moment, what will happen? Your input voltage will be 3.1 volt. The next moment, after this point, the next moment your input voltage will be 3.1 volt. So 3.1 minus 3, this potential will be 0.1 volt. Again your diode turns on. Again your diode turns on, right? So again your diode is turning on. So if it is again turned on, it will again start following the input. So it will follow the input till this point, till 5 volt. Now your capacitor is charged to 5 volt. This capacitor is charged to 5 volt now. Now at the next moment, what is your input? From 5 to 4.9. At the next moment, it is 4.9. So this is 4.9. 4.9 minus 5. Again it is minus 0.1. Again it is turned off. So if it is turned off, the capacitor will retain its voltage because it can neither charge nor discharge. So it will just retain its voltage. So again it will start retaining its voltage. Again it will retain its voltage. Now what will happen at this point? Let's just extend it somewhere here. So after this, what will happen? What is our capacitor voltage? Our capacitor voltage is 5 volt. After this point, this is 5 volt only. After this point, what will be the input? Input will be 5.1 volt. The next moment, the input has increased. So this is 5.1, this is 5. This potential will be 0.1 volt. And if this potential is 0.1 volt, the diode again turns on. If it again turns on, it will again start following the input. It again will follow the input. Capacitor is again following the input till this point, and here till this point, and here till this point. So it will again follow the input till 7 volt. Till 7 volt. It is again following the input till 7 volt. But after that, once it has reached 7 volt, now our capacitor is charged to 7 volt. The next moment it is going down from 7 to it is going to 6.9. Here 6.9, here 7. So what will be the potential here? That will be minus 0.1 volt, and that will turn off the diode. If the diode is turned off, it will retain its voltage. It will always be at 7 volt only, and after that the input is never going higher. The input is always lower only. So to turn on the diode, what do you need? You need the input to be greater than 7 volt, which is not happening. To turn on the diode, you need a input voltage greater than 7 volt. Why so? Because here this is at 7 volt. So V in minus 7. This potential will be V in minus 7. That should be greater than 0 volt. Then only the diode will turn on. So V in should be greater than 7 volt. So it is not happening. Here at this point, what do you say? That input voltage should be greater than 5 volt. Yeah. Here the input is greater than 5 volt. So diode is turning on. Here what would you have said? The input voltage should be greater than 3 volt. Yeah, here the input voltage is greater than 3 volt. So diode is turning on. But here you need V in should be greater than 7 volt, which is not happening because after that the diode, the input voltage is always lesser than 7 volt. So diode will never turn on. That means the capacitor will retain its voltage. So the capacitor will always be at 7 volt. So that will be the steady state voltage of the capacitor, and it will always remain at 7 volt. So that's it. That's the capacitor waveform. So if they ask you the steady state voltage of capacitor, that also you can tell that is 7 volt. Also they can ask you anything. They can ask you V0 waveform. They can ask you steady state voltage of V0. Even if they had asked you the V0 waveform, you could have drawn it, right? You could have drawn the V0 waveform, because till this time you know the VC waveform. So what is your V0? V0 is simply V in minus VC. You can draw, and after that your steady state voltage is V in minus 7 volts. So you can also draw the V0 waveform as well. So everything you can draw in any interview, in any written test, gate examination, everywhere you can draw anything if you have the concept clear. So I will see if there are any other possible question. Let's try to make one more question, and let's end this video with 1 hour. I will try to make one more question that will clear more concepts. Okay, so let me think about it, and then we will see. Okay, so this question I framed. So this will test your, let me put on the mic. I forgot to put on the mic. So this question I framed, and this will test your transient analysis more than the clamper circuit or clipper circuit or anything. It will test your transient analysis. So this time your T is equals to 2 RC. That means your RC is not very large. RC is not very large. This is not the case this time. Because it is equivalent to T by 2. RC is equals to T by 2. So T is equals to 2 RC. That is given. We need to find the value of V0 at 43 T by 4. 43 T by 4. This is the time period T. So you need to find the V0 value at 43 T by 4. So you have to analyze the circuit now. So let's start analyzing the circuit, and we will see what we come across. So for 0 to T by 2, what is happening? For 0 to T by 2, what is happening? The applied input voltage is 3 volt. And if the applied input voltage is 3 volt, what will happen? Diode will turn on. Diode turns on. Now I told you one thing, irrespective of the RC value, the capacitor will simply follow the input because the diode is turned on. So now the VC voltage is completely exposed to the input. This is our VC voltage. This is what I am calling VC voltage. So now our capacitor is exposed to the input because the diode is turned on now. So what is the condition now? Simply the capacitor and there is no need of making the resistor because the resistor is shorted now. This is your output, and this is your VC. This is Vin. Your VC will be 3 volt because VC will simply follow the input. And what will be your V0? V0 will be 0 volt. So for 0 to T by 2, your VC waveform is 3 volt and V0 is 0 volt. Well and good. Now what is happening at T equals to T by 2 plus, or you can say for T by 2 to T. T by 2 to T. What is happening? The input is gone. Input is 0 volt. Input is gone. Here input is gone, but the capacitor is not changing its voltage instantaneously. The capacitor will be at 3 volt only. So the input is gone, but the capacitor is at 3 volt only. This is the diode. The input is gone, that means this is shorted. The input is gone, and this is 3 volt. And then there is this resistance R. This is V0. So tell me what is happening now. This is VC. What is happening? What is the potential across the diode? 0 minus 3. This will be minus 3 volt. The potential across the diode is minus 3 volt. That means the diode turns off. So you can say the diode turns off. Diode turns off. Now in the previous analysis, what was happening? RC value was very large. In the previous analysis, RC value was very large. So the capacitor was not changing its voltage. It was at 3 volt only because RC value was very large. So it can neither charge nor discharge. But now RC value is not very large. Now the capacitor can discharge. So what is happening? This is off now. This is off. So what is your circuit now? Your circuit is simply reduces to this. There is a capacitor, there is no diode, and there is a resistor. This is how your circuit is replaced. Capacitor and a resistor. And across the resistor, this is your V0 waveform. And this is charged to 3 volt in this direction. Ground end is connected to positive supply, negative end is connected to resistor. Negative end is connected to resistor. And what is our VC? This is our VC. So from here you can simply see that V0 is equals to minus VC. And what is VC? VC will simply discharge to 0 volt because the capacitor is trying to discharge. The capacitor is trying to discharge to 0 volt. So your V0 will be minus e to the power minus t by tau. Tau is RC. But here I should not write t by tau, but I should write t minus t by 2. T minus t by 2 by RC, because the time window we are starting from t by 2. So we are having the window of t by 2 only. We are having the window from t by 2 to t. That means the window of t by 2. So in t by 2 time, how much it will discharge? So V0 value at time equals to t. V0 value at time equals to t. That will be minus time t equals to t. So it will be t by 2 RC. And value of t is given as 2 RC only. T is given as 2 RC only. So the value will be 3 into e to the power minus 1. That would be some 1.1 volt as far as I remember. Or we can calculate again. Yeah, 1.1. So it will be minus 1.1. Minus 1.1 volt. So basically, what did you understand here? So your V0 value at t, that is minus 1.1 volt. And what will be your capacitor value? Capacitor voltage value, that will be 1.1 volt only. Right? Capacitor voltage value will be 1.1 volt only. This will be 1.1 volt. This is getting discharged like this. So it will be discharged till 1.1 volt. Well and good. So we can try making the V0 and VC waveform. This is the VC waveform I am making, and this is the V0 waveform I am making. So initially for 0 to t by 2, what was happening? VC was 3 volt and V0 was 0 volt. 0 to t by 2. This is t by 2. It was at 3 volt only. And this was at 0. Then after t by 2, what was happening? Capacitor is getting discharged. So it is discharged to 1.1 volt. It is discharged to 1.1 volt. This potential is 1.1 volt. What about V0? V0 value at t by 2 will be what? V0 value at t by 2. Suddenly the V0 value is changed to minus 3 volt. At t by 2 plus, what is the value of V0? V0 value at t by 2 plus. V0 value at t by 2 plus. Tell me the value of V0 at t by 2 plus. At t by 2 minus it was 0 volt. At t by 2 plus it will be what? Minus 3, right? Because at t by 2 plus this is the condition. At t by 2 plus this is the condition. This potential is 0. This is grounded. 0 minus 3. So value is minus 3 volt. And from minus 3 it is trying to go to 0. From minus 3 it is decreasing to 0. But it decreases to minus 1.1 volt only. So it is trying to go to 0, but it decreases to minus 1.1 only. This is your, let's assume this is your minus 3 and it It is trying to decrease, but it decreases to minus 1.1 only. Decreases to minus 1.1 only, right? Now what is happening? At t equals to t plus, what is happening? Input is again 3 volt. Input is again 3 volt. The capacitor is not changing its voltage. Let's assume it is at 1.1 volt only. This was our diode, and this was the resistor. And here this is 3 volt. This is 3 volt. What will happen? 3 minus 1.1. This potential will be 1.9 volt. What will happen? Diode turns on. The diode turns on. Diode turns on. This is our VC. Diode turns on. Now what do you think? The capacitor will exponentially charge to 3 volt or suddenly it will be charged to 3 volt? I want your answer. If you have studied network analysis from me and if you give the wrong answer, it should not happen. Okay. And let's try other things as well. That now I am asking you, the diode is turned on now. Now I am asking, the capacitor will be charged to 3 volt immediately or exponentially? Immediately, right? Because the diode is turned on now. If the diode is turned on, there is no use of resistor, there is no use of RC, nothing. Diode is turned on, so 3 volt is directly exposed to the capacitor. Also you can see there will be infinite current flowing through the resistor. Sorry, there will be infinite current flowing through the capacitor, because 3 minus 1.1, 1.9 volt, 1.9 by 0. What do I mean to say? This is the capacitor, this is 3 volt. Now what will be the VC value now? Suddenly it will be 3 volt. There is a property of capacitor that it cannot change its voltage instantaneously, but here it will change its voltage instantaneously. Why so? Because there is infinite current flowing through the capacitor. How infinite current? Look, what is the voltage across the capacitor? That is 3 volt. What is the resistance? Forget about the capacitor voltage. Forget about this. Let's try finding the current in the resistor, in this circuit. Let's try finding the current in this circuit. So that will be 3 by, how much resistance is there? Initially the capacitor will be shorted. So how much resistance is there? 0. 0 resistance is there. So what will be the current? Infinite. That means there is impulsive current through the capacitor. If the current is impulsive, that means the capacitor will change its voltage instantaneously to 3 volt. Or you can see that the capacitor is exposed to the 3 volt directly. So the capacitor voltage has to go to 3 volt. And V0 will be 0. So for T to 3T by 2, for T to 3T by 2, what is happening? VC voltage will be, this is our VC. VC voltage will be 3 volt and V0 will be 0 volt again. So again all this is happening, that again it is 3 volt and again it is 3 and again it is 0. This is happening till time 3T by 2. After that what will happen? Again it is charged to 3 volt. VC is again charged to 3 volt. Again it is charged to 3 volt. So for at T equals to 3T by 2 plus, what will happen? Diode will be off. The same, this same thing will be happening at 3T by 2 plus. The same thing will be happening. At 3T by 2 plus, input will be gone. What will happen? It is charged to 3 volt. So 0 minus 3 volt, diode will be off. What will happen? Again, the capacitor will start discharging and V0 will try to decrease. V0 will again go to minus 3 volt. From minus 3 to again it will try to go to 0. So the same cycle will keep on repeating. At 3T by 2 plus, diode will be off. Diode will be off. Capacitor discharges. So the same cycle will keep on repeating. The cycle will keep on repeating for V0. And again it will come to 0. Again it will come to 0. And it will just keep on happening. this time is 2t, this time is also 2t, this time is t. Again it will come to 0, and here again it will go to 3 volt. So the same cycle is happening. Now we need to make a comment on V naught. So I will draw the V naught waveform more clearly so that you can comment on V naught. We don't need to make comment on VC, but we need to comment on V naught. So what was our V naught? 0, then -3 discharging. 0, then -3 discharges. Discharges like this. -3 to -1.1, you can say like that. And then again 0, then again discharges in the same manner. This cycle is continuously going. So here you can see this is t by 2, this is time t, this is 3t by 2, this time would be 2t. So this is your V naught, which is periodic. This is -3 volt. Now what do you need to find? You need to find V naught value at 43t by 4. V naught value at 43t by 4. This is what you need to find. One thing I know, it is periodic by time period t. V naught is periodic by time period t. By time period t. This is what I know. What I can see here is that it is written 10t plus 3t by 4, right? Isn't it? It is written 10t plus 3t by 4. So V naught value at 43t by 4 can be written as V naught value as 10t plus 3t by 4. That would be equals to V naught value at 3t by 4. That's it. V naught value at 3t by 4. That would be equals to V naught value at 3t by 4. Where will be 3t by 4? Here. This will be our 3t by 4. So this value only we need to find. V naught value at 3t by 4. This value only we need to find. That's it. So what is our V naught t? V naught t equation was -3 e to the power minus t minus t by 2, because we have the window from t by 2 only. T minus t by 2 by RC. And how much window is this? T by 4 time only. So you can directly, if you have good intuition, what you can see that V naught, okay, capacitor is getting discharged, so output will be e to the power minus 3t by RC. It is getting discharged, but we have the window of t by 4 time only, so e to the power minus t by 4 RC. Value of t is given 2 RC, so 2 RC by 4 RC, it will be 1 by 2. So answer would be 3 minus 3 into e to the power minus 1 by 2. That would be your answer. Or you can write down the equation in this manner, but better to solve by the concept of window, that you have a window of t by 2 time. You have the window of t by 2 times. So the capacitor is getting discharged, or output is getting charged, the capacitor is getting discharged. So you can see that from -3 to it is trying to go to 0 only, but it will reach till 1.1 at 3t by 4. It has the window of t by 4. So here you can put 3t by 4. So V naught value at 3t by 4. Next page we can write. So V naught value at 3t by 4 would be -3 e to the power minus 3t by 4 minus t by 2 by RC. So it would be e to the power minus t by 4 RC. Value of t is given as 2 RC. So it would be -3 into e to the power 2 RC by 4 RC. That would be equals to e to the power minus 1 by 2. that would be equals to minus 1.8 volt. So V naught value at 3t by 4, and that would be equals to V naught value at 43t by 4. So your final answer V naught value at 43t by 4 will be minus 1.8 volt. So the circuit looked like a clamper circuit, but these kind of question also can be asked, because nowadays they are framing very good question from analog electronics. So you should have a very clear idea of everything that you are studying. Why RC value is very large? If RC value is very low and the input is square wave, what should happen? If it was plus 30, what should happen? The output waveform, how will the output waveform look like? So this was the complete question of transient. There is no diode circuit, there is no clamper circuit. This was completely based on transient. First the input is 3 volt, so the capacitor is charged to 3 volt, output will be 0. Then input is gone, so output is trying to discharge to 0 volt. So minus 3 to it is trying to go to 0, but you have the window of t by 2 time only. So in t by 2 time it is discharged to minus 1.1 volt only. So it is discharged to minus 1.1. Then again the input comes. So what will happen? Again the diode is turned on. Now the diode is turned on. Now there will be no exponential charging. There will be instantaneously charging because of the infinite current. So again it is 3 volt. Then again it is discharged, 3 volt, discharged. So the waveform is periodic. So they are asking 40 at 43t by 4. That means at 3t by 4 will be the same, because 3t by 4 plus 10t will be the same. So V naught value at 3t by 4 will be this. And we found the value of V naught value at 3t by 4, that is minus 1.8 volts. So it will be the same at 43t by 4 as well. So that is your final answer. So that's how you will be solving a very good problem in the examination. We will see the complete analog electronics in this manner only. So I hope you enjoyed the video. If you enjoyed the video, please do share it with your friends. In the next video, we will study about peak detector circuit. Okay, thank you.